Alright, does y'all look like that? Something like that? How are the intercepts of a graph affected by reflection across the x-axis? Explain. Did our x-intercepts even change at all? No, they crossed each other in the same spot, didn't they? So, we're going to write the x-intercepts stay the same. Because the points on the axis you are reflecting do not change. If we look at our y-intercepts started out at -2, then it went to +2. So our y-intercepts are opposite of one another. So I'm going to say the y-intercept are opposite one another. All right, we're going to skip examples 3 and 4. So you can write skip over those, and we're going to go straight to number 5. Once I get this plugged up. Alright, so number 5 says, what transformations of f of x is equal to x squared result in the function g? So if I'm just looking at that equation, we can just kind of talk about it. What's the negative out front of the parentheses going to make it do? What's that negative out in front of the equation make it do? Anybody remember? We just talked about it, huh? Flip, reflect, right? So we know that we're going to have some sort of reflection across the x-axis. And then the 1/3 on the inside of my parentheses actually means that there is going to be a horizontal stretch by a factor of 3. But we're not, I told you yesterday we wouldn't talk much about those, so we're not worried about, or we're not going to graph any of those hardly. So don't worry too much about that. The next equation is g of x is equal to x minus 4 squared plus 5. So let's take a look. Let's break it down. What does the minus 4 on the inside of our parentheses tell us? You know, if it's inside, we're either moving left or right. So what is the minus 4 going to tell us to do? Move which direction? What's this graph doing? 1, 2, it moved to the right, correct? All right, so then the plus 5 tells us that not only are we going to move right 4, but what are we going to do with that plus 5? Move up 5 units. Y'all agree with that? I know it doesn't look it here, but this went up by 2s, 2, 4, 6, 8, so it did move up 5 units. So this graph, the translation of this graph was 4 units right and 5 units up. So we've got 2 practice problems here. What transformations of the graph of f of x is equal to the absolute value of x are applied to the graph of the function g? So let's break it down. Let's take a look at our first thing we come across. That's an a value. If a is 1/2, you can go back to that worksheet we filled out at the beginning of today. If a is 1/2, what does that tell me? Remember that worksheet we filled out at the very beginning of class today? Compress, yep. So I'm going to write compress by 1/2. And then the +3 on the inside of those absolute value bars tells me that it's going to move which direction? Left 3. Yep. All right, those were the only 2 translations that this graph had. The next graph, or the next equation, is negative absolute value of x plus 2. So negative, what does the negative tell us it's going to do? We just talked about it. Yep. Reflect is correct. Reflect over x-axis. And then the +2 on the outside of the absolute value bars tells me it's going to move which direction? Yep, up 2. If it had been on the inside is when it moves left. All right, everybody good with example number 5? Our last example for today. Says a scenic train ride makes trips on an old mining line. The graph shows the distance in the distance y in kilometers of the train from the station x minutes after the ride begins. What equation represents the distance from the station as the function of time? What is its domain? So it's saying at 0, 0, we haven't started our train ride and we haven't gone we're still at the station. But by 15 minutes, we should be 15 kilometers from our station. In total, this ride takes 30 minutes to get back to the station, is what that graph is saying. It says the graph shows a reflection of an absolute value graph across the x-axis and a translation upward to the right, or upward and to the right. The general form of this absolute value equation is y is equal to negative, I guess because it's flipped, because it's reflected. A times x minus h, or a times the absolute value of x minus h plus k, where the point hk represents your vertex, and negative a indicates that the graph opens downward. So because we see that it opens downward, we already know that a is going to be negative. Substituting the point of the vertex 15, 15 for hk gives the equation of y is equal to negative a times the absolute value of x minus 15 plus 15. So do you see how they just plug the vertex into that equation up here? And what they do now is they use the point 0, 0. You could use this point right here, 0, 0, or you could even use the point of 30, 0, either one, to plug in so that you could then solve for a. So we can let them do all the work. You see they plugged in 0, 0. They simplified 0 minus 15 to get negative 15, but the absolute value of negative 15 is positive 15. But then you had positive 15 times negative a. That's where they got negative 15 from. And then they were able to solve for a by subtracting 15 from both sides and then dividing by a negative 15. So then they got their equation. So now you can write the equation for a distance as a function of time. And according to the graph, the train returns to the station after 30 minutes, so the function's domain is 0, 30, because it starts at 0 and we return back by 30 minutes. They didn't really give us much work to do there. So how would the graph and the equation be affected if the train traveled twice as far in the same amount of time? So to travel twice as far, that means that we would need to multiply by what? If we're going twice the distance, we would need to multiply by 2. So that means that there would be a vertical stretch by a factor of 2. And so our new equation, so distance traveled was multiplied by 2. So not negative, but 2 times negative x minus 15 plus 15. This really could have been y. I wrote d for distance, I guess. I wasn't thinking. And then what we have to do is we have to distribute the 2. We're going to distribute the 2 to the negative. We do not distribute within absolute value bars. You can't do that. So our new equation is negative 2 times the absolute value of x minus 15 plus 30. One more before we get started on just our homework problems. The function f of x is equal to the absolute value of x is translated 3 units right and 2 units down, and then stretched by a factor of 4. What is an equation of the transformed function g? So what I actually wrote out to the side was this. This was the graphing form. Remember I told you earlier that this was the graphing form of our absolute value equations? So what I do when I see something like this is I go through and I underline or highlight anything that I think might be important. And then to make my life a little bit easier, because sometimes I don't write it in order, I write A equals, H equals, and K equals. That way when I figure out what these 3 letters equal, I can just plug it straight into my equation. Okay? So the function f of x is equal to the absolute value of x is translated 3 units to the right. Well, which of these letters translates right? A, H, or K? Y'all look back at, yep, H. So if I'm translating 3 units to the right, H, right now we're going to keep it a positive 3, and I'll tell you why in a second. We're translating to the right, so if you think about the right of your graph, that's the positive x values, correct? All right, now we're going 2 units down. Is that A, H, or K? K. And if I'm going down, what do you think it's going to be? Negative, right? And then stretch by a factor of 4, so that is your A value. So if I'm plugging in, we got y is equal to A. We just plug it in. X, y'all may or may not remember what I told you yesterday, but H always lies. H lies, K tells the truth. So if we have H being a positive 3, what do we really write it as? X minus 3, yep. And then K tells the truth, so it's written as minus 2. And that's your equation. All right, now what I want you to do is I want you to do numbers 1 through 11. But I'm going to kind of help you out on these real quick because it tells you. This says to just graph each function, but your paper says to graph each function and its parent function. So I'm gonna write out to the side what the parent function is, so that because we hadn't really talked about those, and I know it's been a minute. So, are y'all okay if I don't write y equals actually? We all know what this means. All right, absolute value of x. You know, if you put it in the calculator, you can put it in y equals. But it's wanting you to graph both of these, okay? Both the parent function and the transformation. And I want you to skip 12. Also, if you get home, because I know we only have 10 minutes, if you have an iPhone, there's an app you can download. It's called Calculate 84, and that gives you this graph right here. I mean, this calculator. And if you have a Android, it gives you, I think it's called Wabbit Emu. Is the app you can download, and those will give you the actual calculator that we have